a slightly different way of doing it though. Basically here, what I'm going to do is I'm going to show you how to solve those conversion problems using proportions, okay? And also this happened in my college algebra and trig class yesterday. If the PowerPoint freezes for some reason, you know, do the raise your hand feature, speak into your microphone, let me know, okay? I think people had trouble seeing it, but if they refresh their page or whatever, then it was easy to see, so, okay? All right. Okay, I mean, what I did last time was correct, the factor label method. I just thought this method might be a little bit easier to understand, the proportion method, okay? Okay, so I'm going to begin. Again, if it freezes and you can't see what I'm doing, please, you know, use the raise your hand feature, you know, speak into your mic, whatever, okay? Okay, so I'm going to begin. Wait, am I recording? Yes, I am. Okay, so this is just kind of a review from last time. What we saw last time was rates. And remember, a rate, it's really just a ratio of one quantity to another one, which we can write as a fraction. You know, we saw examples last time, right? Namely, you know, we saw with speed, you know, you're driving a car and you're driving at like 25 miles per hour, meaning per 1 hour, that's a rate. Or if you go to, I don't know, Walmart or something, or any grocery store, and you're buying, say, apples or something, right? Or oranges or whatever, and they say like, you know, it's 2 oranges, wait, so each orange costs $2.19 or $2.19 per orange. You know, that's a rate. Or just in general saying $2 per pound, something like that, that's a rate. So rates are all around us, just like conversions are. And in particular, we can have what's called a unit rate. Namely, a unit rate is when the denominator is 1. So in that example I said, you know, in that example I said with driving your car, 25 miles per hour, right? 1 hour, that's a unit rate. That's a unit rate. Just when the denominator is 1, you know, quantity 1, that's a unit rate. And as I just said, and I said this also last time, we did solve these kinds of problems using the factor label method. That's one way to solve them. I'm not sure if people really understood it. It could have been my fault the way I was explaining it, but I want to show another way in how to solve those problems dealing with proportions. Proportion basically is just when you have one ratio equal to another, or since we're writing them as fractions, one fraction equal to another. So for instance, you can have something like this, like 1 over 3 equals 3 over 9. These are just fractions now, but they could denote a rate. You know, that's an example of a proportion. Here's another one. You know, you have one ratio or fraction actually equal to another. Now, with equations, they can be either true or false. How do you know if they're true or false? That's where this comes into play. Namely, this is going to be true. So in other words, this equality holds when, or exactly when, this holds. And this is where that idea of cross multiplying, wait, let me get that laser thing. This is where the idea of cross multiplying comes into play. Namely, if you cross multiply or take cross products, I think that's also how they're called, and equality still holds, then the original equality was true. These two turn out to be true statements. You could just multiply it out. For instance, 9 times 1 is 3 times 3. 4, you know, both equal 9. 4 times 14 is 56, which is 8 times 7. So we have that, and we can use these proportions to solve problems with rates and conversions, unit conversions. And that's what we're going to do. So this is just saying what I said a second ago, namely we can solve these using proportions. So I figured it'd be good. So here are just some examples of rates that I gave last time as well. You know, the first one, speed of a car, 25 miles per hour. Generally, when you have per in here, PER, that indicates a rate. That will indicate a rate. Okay? All right. Another one here is, as I was saying with the grocery store, $2 per pound. Okay? You know, that's an example of a rate. And you could actually invert, that is, flip a rate, you know, it's a fraction, and you get another one. So if we take the 25 miles per hour, we can flip it and get 1 hour per 25 miles. That's another rate. It's not a unit rate anymore, right? These are unit rates because you have a 1 here. I mean, the 1's not written, but it's understood to be there. So this is not a unit rate, but it's still a rate though. Okay, that's fun. Let's actually solve an example. So let's suppose we're driving 25 miles per hour. So the first one up here is the speed that we're driving at. That's the rate at which we're driving our car. We want to know how far we're going to travel if we drive for 5 hours. So in other words, the speed of our car is not changing. So somehow we're able to drive 25 miles an hour exactly without slowing down or speeding up for 5 hours. That's what we're assuming. And we want to know how far we're going to travel. Well, from the factor label method, you can do that. You know, you could solve this, that is. But I'm going to show you using proportions. Okay, so we don't know how far we traveled. We're going to let x be the distance that we're traveling. So x is how far we're going. Well, we have two rates here, don't we? We have this one, 25 miles per hour, right? We also have the other rate where x is how far we're going, right? And we're driving for 5 hours. So this is another rate. We don't know what x is, but that's okay though. But this is another rate. Both of these have to equal to each other though. And how do I know that? Because they both tell us the rate at which we're driving. You know, the speed at which we're driving our car. That is, both of them tell us the rate at which our car is moving. So they both tell us the same thing, how fast we're going, basically, speed of a car. So they have to equal each other. Or I guess if you want, you could think of it this way. If we're driving 25 miles per hour at that same speed, how far are we going to drive in 5 hours? So they have to equal each other. Okay, well, how do you figure out what x is? Well, you could take the units off, which is what I do. You know, they cancel. And then you just take the cross product. That is, you cross multiply. So here we'll have 5 times 25 equals 1 times x. Right? And so we get x is 125 miles. That's all. So that's what we end up with. I mean, in the end, you're just multiplying, which is what the factor label method has us do. But, you know, this is fine. Notice also the units are in the same corresponding spots. You know, on top here, we have miles. On the bottom, we have hours. Okay, you want to make sure the units are in the same corresponding spots. Otherwise, your answer is not going to be right. Okay, so that's one example. So here's an